Hello everyone. In today's class we are going to discuss about the conformations in ethanes. Conformations in ethane. Before we start with the topic, I just want to discuss about the structure of methane and ethane first of all. How is methane and ethane structure? Let's start with structure of methane. As we have already done in alkanes, all carbon they undergo sp3 hybridization. Now what is carbon's configuration? It is 1s2, 2s2, 2px1, 2py1. This is the ground state configuration. Now what about the excited state configuration? It is 1s2, 2s1, 2px1, 2py1, 2pz1. All these four orbitals will participate in hybridization and will form sp3 hybridized 4 hybrid orbitals. All will be half filled like this. You can see here, this is one hybrid orbital, one bigger lobe, one smaller lobe, and this is half filled. Then this is another hybrid orbital, one bigger lobe, one smaller lobe, half filled. Then this is another hybrid orbital, because tetrahedrally these four orbitals will be arranged. So they should be like this. Now all these four sp3 half-filled hybridized orbital will overlap with the half-filled 1s orbital of hydrogen. And that is how we will get a tetrahedral molecule where the bond angle is 109 degree 28 minutes. How can you visualize the molecule? The molecule can be visualized like this. Here you can see that this orange color is for the carbon, and these four are the 4 hydrogens. All are not in the same plane, they are in different plane. This is the tetrahedral geometry. You can see one of the atom is pointing towards you, or it may be pointing towards me. Or one atom, means what I am trying to say, this is how the tetrahedral structure is. This is not a planar structure. So this is the structure of methane. Now what about the structure of ethane? How ethane will be there? In case of ethane, both the carbons will undergo sp3 hybridization, and that is how they will be forming this type of structure. This is one hybrid orbital of one carbon, this is another carbon, this is another carbon, and this is one more carbon. So these four are the hybrid orbital of one carbon. 3 of them are overlapping with hydrogen like this, and the fourth one will overlap with the sp3 hybridized half-filled orbital of another carbon in this way. This is the another carbon, second hybrid orbital, third hybrid orbital, and fourth hybrid orbital. All are half filled. Here also 3 will be overlapping with the half filled hybridized orbital of 3 hydrogens like this. So this is how the shape of ethane is. Now we are starting with the conformations. In structure of ethane we can well observe that this overlapping of the orbitals will be forming a sigma bond, and because this overlapping is taking place along the internuclear axis, so that is why the rotation of this carbon-carbon bond is quite free. Here you can observe, this is the structure of ethane. This orange color is one carbon, green color is another carbon. These are the 3 hydrogens bonded with this carbon. These are the 3 hydrogens bonded with the another carbon. So this is how the structure of ethane molecule. Right? Now we are starting with the conformations in ethane. Now what about the conformations in ethane? Just see, as we discussed just now, that the rotation along carbon-carbon sigma bond is quite free. Why is it free? Because it is overlapping along the internuclear axis. You can well observe it that we can freely rotate it in this way. Now one more thing you need to observe, that when I'm rotating it, the arrangement of atoms around this bond is changing. The arrangement of hydrogen atoms is changing. One more thing you need to observe, that I am keeping one carbon atom stationary. I am rotating only the another carbon, right? So you can see that when we are rotating the carbon at certain angle, we are getting the different arrangement of hydrogen atoms, and because of the different arrangement of hydrogen atoms, we are getting the different conformations, right? So what are conformations? Basically, conformations are the different spatial arrangements. Spatial arrangement means the arrangement in the three-dimensional space obtained because of the free rotation of carbon-carbon sigma bond. We can freely rotate the carbon-carbon sigma bond in this way, and you can see the structure, the arrangement of atoms around the this bond or around the carbon atom is changing because of the single rotation. If I'm rotating like this, I'm getting this structure. I'm rotating at this angle, this is the structure. Rotating at this angle, this is the structure. You can well observe how the position of hydrogen atoms is changing, and because we can rotate it at infinite number of angles, that is why infinite conformations are possible, right? So what are conformations? Conformations are the different spatial arrangement obtained because of the carbon-carbon sigma bond free rotation along the internuclear axis. How can I show it? I can show like this. This is one carbon, this is another carbon. This is how the arrangement of hydrogens is, like this. And when I rotate, the arrangement of these hydrogens will be changing, and the changed arrangement or the different arrangement of the hydrogens around the carbon atom is called as the conformations. We are getting infinite number of conformations, so these are called as conformations, or these are called as conformers, or these are called as rotamers. All are one and the same thing. They are also called as rotamers. They all are same. Now let's see. This is the arrangement we are taking. Now, if we are supposed to draw it in a plane of paper, how can we do it? There are two ways to do it. But before that, I just want to tell you the kind of conformations. Like, I'm keeping this orange one constant and I'm rotating this green. Say I'm rotating it at 180 angle. How am I getting it? At 180 angle. You see that whatever was above the plane earlier, now it is below the plane. Or you can say whatever was towards you earlier, now it is towards me. Right? So that is how the arrangement is changed. You can see the earlier initially this hydrogen and this hydrogen, both the hydrogens were in the same plane. Now when I rotated it at 180 angle, you can see the arrangement is just opposite. So this is what? This is the one conformation, one extreme, I will say. And what is this called as? This is called as staggered conformations. Staggered. There is another one also. What is that? That is eclipsed conformations. We can have eclipse conformation also, like eclipsed. It is just like the eclipse, meaning that when all are in the same plane. You can see that not in the same plane means like hydrogen on this carbon is just in the alignment of the back carbon. The hydrogens present and at both the carbons are in alignment with each other. Then we say that this is eclipse, because one carbon hydrogen will be going to cover or will be shade the other one. So that is why we call it as eclipsed. Now if I rotate it at intermediate angle like this, you can see I'm getting something different. So this type of conformation is called as skew. So we are having two extremes. One is staggered, another is eclipsed, and intermediate is called as skew. Right? Now how can we represent in the plane of paper? There are two ways to represent. One is Newman projection formula. Newman projection formula. Now in Newman projection formula, how do we view the molecule? We view the molecule from the front. You see, when you see the molecule from front, you are able to observe the molecule like this. You are observing it from front. So you are not able to see the back carbon. So how will I represent it? I will represent it in this way, this is the front carbon which is visible to you, surrounded with 3 hydrogens in this way. Is it the same way it is visible to you? You can see the front one is visible like this. The orange one is the carbon and these are the 3 hydrogens. Same thing I did here. So the front carbon I am representing with the dot. Now what about the back carbon which is not visible to you? I am representing with that a big circle like this. Now here you can see this is how the arrangement is. Now here you can see that all the atoms at carbon 1 and 2 are in alignment with each other. Like here is one hydrogen of this, here is another hydrogen of this. Here is one hydrogen, here is another hydrogen. Means they are going to be in alignment. So what is this conformation called as? This is called as eclipsed. So this is the eclipsed conformation when the hydrogens of the front carbon only are visible, the back is not visible, but still we are showing them like this, in this way. So this is what, this is eclipsed conformation. Now I am rotating it like this. I am rotating it in this way. Now you can see the arrangement is just opposite. And this is what, this is called as staggered. Right? How will we show it? This is the point for the front carbon. Here are the 3 hydrogens bonded like this. Now what about the back carbon? You can see in the back carbon it is in this way. Here is the carbon of the, here the hydrogen of the front carbon, here the hydrogen of the back carbon. So how can we show it? We can show it in this way with the big circle, and this is the hydrogen of the big circle, the back carbon. So this is eclipsed, this is staggered. This is how we can represent the conformations of ethane. By Newman projection formula, what are we doing? We are viewing the molecule from the front. Right? Now there is another way to do it in the plane of paper. What is that another way? The other way is by Sawhorse projection formula. We can do it by Sawhorse projection formula. How can we do? In that case, we will be viewing the molecule from the side. And that is how the carbon-carbon bond will be visible to you, and you will be showing it with an elongated slanting line like this. You are viewing the molecule from the side. If you view the molecule, just see the difference. When you were viewing it from front, how was it? And now when you are viewing it from the side, then how was it? Right? So how will we represent it? According to Sawhorse projection formula, the molecule is viewed from the side, and we will show the carbon-carbon bond slightly elongated and tilted. This is one carbon, this is another carbon. The carbon which is at the bottom is towards you. The carbon which is at the top is towards me. Right? Now how the hydrogens are present? They are present in this way. H, H, H. Here also H, H, H. So all of them are in alignment. That is why, what is this conformation? This is eclipsed. Now what about if we rotate it at 180? Then say this is the carbon towards you is as it is. We rotated the back one, and the back one will become like this. H, H, H. Just opposite, it is staggered like this. Now you can observe that. Can you please tell me which conformation is this? This is eclipsed because hydrogen, 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 hydrogen. So they are all in alignment. Now I am rotating it at 180 degree. You just see how the arrangement is going to be. This is what? This is staggered. So that is how we can have two extreme conformations, eclipsed and staggered. Now we are coming to the next point. Which of the two is more stable? Stability of the various conformations. Now we are coming to the next term, that is stability. Relative stability of various conformations. This is the next thing we are talking about. Now stability depends upon the repulsive or the attractive interaction. Repulsive interaction. Now repulsive interaction between what? Repulsive interaction between the electron clouds of carbon hydrogen bond. Now here you can see that these are the two carbons. If we take the staggered conformation, the carbon hydrogen bonds are at maximum distance. So there is minimum repulsive interaction. What do we call it as? What is this repulsive interaction called as? Repulsive interaction is named as torsional strain. Torsional strain. What is this torsional strain? Torsional strain is the repulsive interaction between the electron clouds of the carbon hydrogen bond of two carbons. Now because in case of staggered conformation, the carbon hydrogens are at the maximum distance, that is why there is minimum repulsion, right? There is minimum torsional strain. So minimum torsional strain in what? In staggered. In staggered conformation, there is minimum torsional strain. That is why it should be maximum stable. Maximum stability. One more thing, we can relate it in another way also. What it is? There is another term, that is dihedral angle. Dihedral angle, or this is also called as torsional angle. What is this torsional angle, or what is this dihedral angle? It is the angle of rotation. If I rotate it more, like if I am rotating it maximum at 180 degree, the electron clouds are at maximum distance. So dihedral angle is 180 here. We are rotating it at 180 degrees. So that is how now the electron cloud is at maximum distance. That is why there is minimum torsional strain. That is why there is maximum stability. So we can say that also, that is maximum dihedral angle. Maximum dihedral angle, minimum torsional strain, maximum stability. In which case? In case of staggered. Now what about eclipsed? In case of eclipsed, we know that these are in alignment. These are in alignment like this. So because of this reason, because they are in alignment, because of this particular reason, the electron clouds of carbon hydrogen are very much close to each other. They are at minimum distance because of the minimum dihedral angle. So eclipsed mein, what is the scenario? In case of eclipsed conformation, there is minimum dihedral angle. Minimum dihedral angle. That is why maximum torsional strain, that is why minimum stability. So which form or which conformation of ethane is most stable? That is staggered. And which is minimum stable? That is eclipsed. But the difference between the energies of the two, we know it very well. More stable means less energy, and minimum stability means more energy. But the difference in the energy of these two conformations is just 12 kilojoule per mole, which can easily be obtained even at room temperature just by the vibration of the molecules or in other ways. So that is how they keep on exchanging the structure. That's all about the conformations of ethane, their stability. Thank you.